this video lecture, you're going to understand about ARM processor and what ARM does and what ARM company is going to manufacture, how the ARM processor is different, and how the ARM architecture is evolved, and how the ARM architecture is different from a general processor. Okay, so let us start with the ARM introduction part. Okay, so guys, so let us start with the ARM introduction. Guys, you might have already known what is the ARM full form. ARM full form is Advanced Risk Machine. It's a risk machine, but it's not a simple risk machine, and it's an advanced risk machine. And moreover, guys, this ARM is a architecture. It's a 32-bit or 64-bit processor architecture, which is designed by the ARM company itself. ARM is an architecture also, and ARM is a company also. This ARM company is a British-based company which is located in Cambridge, England. They have started producing ARM processor in 1985. Now still they are producing up to 32-bit and 64-bit ARM 32-bit and 64-bit processors. And after developing these processors architecture, they will give the license to the various companies like NXP, like Cirrus Semiconductors, like Atmel companies to develop their own microcontrollers. Okay, so this information we will discuss with the slides, guys. Yes. So when we say ARM, it stands for Advanced Risk Machine, and it is a processor. Okay. And one more thing, guys, here we need to notice. So ARM stands for Advanced Risk Machine, and before it was known as Acheron Risk Machine. So in when they started the first processor, they have given a name called as Acheron Risk Machine, but now it has been modified and renamed as a Advanced Risk Machine. Yes. So I already told you guys, ARM is a British-based semiconductor company which is going to develop ARM architecture for 32-bit and 64-bit processors. The same thing you can see, ARM is a British-based company which is going to develop a software, and also it is going to develop ARM architecture which is based from Cambridge, England. So already I told you, originally the ARM was known as Acheron Risk Machine. Nowadays it's called as Advanced Risk Machine. Okay, the primary business of this ARM company is to produce 32-bit and 64-bit ARM high processors, high-end processors with a high accuracy. I already told, guys. So ARM company which is going to develop architecture for 32-bit and 64-bit ARM processors, which will be operating at 32-bit and 64-bit and with a high performance. And it is a basically RISC architecture. So RISC architecture in the sense a reduced instruction set computer. It's not a complex one. The instructions are very simple and very less number of instructions they're going to utilize in the ARM processor. Right? So ARM develops architecture for 32-bit and 64-bit, and also they will give the license. Okay, so these ARM company will not manufacture any microcontrollers, but they will manufacture processors, and they will give the license to the various companies to develop their own microcontrollers by the companies. So who wants to design their own microcontrollers or system on chip or system on modules, ARM will be giving a license to those companies. Okay, some of the companies I have listed here. Example, Atmel. Atmel is the one company which is manufacturing microcontrollers of 32-bit and 64-bit by taking the architecture from the ARM. Like that, various companies are there. Cirrus Logic is there, Freescale Semiconductor is there, NXP is there, OK is there, Samsung is there, Sharp and STM32, STM Microelectronics and Texas Instruments, and various companies are there. Very few I'm just listing out here. Okay. So because of this ARM, ARM will take very less power, and it is very less in order to it will take a very less power, and also it will it's a very low cost. Okay, so because of this, so most of the applications like mobile applications, laptops, tablets, computers, and most of the embedded system applications are developed using this ARM processors, and it's very lightweight, and it is a very light, and it will take a very less power. So that is the main reason where you can see the applications of your ARM processor in the laptops, in the phones, or in the iPhones or maybe in the embedded system. Okay, so these are all the applications which are based on your ARM processor. So guys, we will move to the architecture of the ARM processor, and before that we will study what are the features of the ARM processor. So let us move to the features of the ARM processor. Yeah, so ARM processor also used in the desktop and servers. So of course, I told you already, laptops also it will be used in desktop. Also we will use servers. Everywhere we will use this ARM processor. So what are these features of this ARM processor? So guys, I already told you ARM is a 32-bit processor. ARM is a 32-bit processor. It uses 32-bit ALU. It uses 32-bit registers. It uses 32-bit registers. There are totally 16 registers are there. R0 to R15 are there, and 7 operating modes are there with the ARM, and one separate special mode is there called as a thumb mode. So this thumb mode is able to operate ARM in the 16-bit mode. So that also we will see. Okay. So what are the important features of this ARM processor? Now we will understand. The first important thing, ARM is a 32-bit processor. I told you already, ARM stands for Advanced RISC Machine, and it is a 32-bit processor. Okay, it operates 60 to 100 megahertz. So ARM will be operating always with a high speed. Some processors will be operating at 60 megahertz, and some processors will be operating 100 megahertz. Even it is more than 100 megahertz. Okay, but if you compare this speed with a regular microprocessor, it is going to be very less. A regular microprocessor will be operating around 10 to 20 or maximum 30 megahertz, but ARM processor operates at minimum 60 to 100 megahertz. ARM uses instructions with a 32-bit. Majority of the instructions of the ARM are 32-bit. Yes, one important thing with respect to ARM is, so it also supports a 16-bit operating mode. So this important thing we should understand here, ARM also supports a 32-bit, and also it supports the 16-bit wherever we want to reduce the space, or wherever we want to reduce the memory of the program, or size of the program, or where the memory constant is available in the applications, then we can use a thumb mode. So thumb mode is a 16-bit operating mode, and it is going to reduce the program size while execution or while creation of the hex file. So how to do that, we will explore later. So it uses 32-bit address bus. ARM uses 32-bit address bus and also 32-bit data bus. There are two buses are there. One is 32-bit data bus and one is 32-bit address bus. Both are unified. Unified in the sense both are multiplexed here. Address bus and data bus both are multiplexed and using ALE bit. So I will explain you in the next slide what is the ALE. ALE stands for address latch enable. Using that pin or using that bit, we are going to demultiplex address bus and data bus. So that is both are multiplexed together, address bus and data bus. Yeah, ARM follows a three-stage pipelining. ARM follows a three-stage pipelining. So one is called as a fetch, one is called as a decode, and one is called as execution. So what do you mean by fetch? Fetch in the sense processor is going to fetch the opcode from the memory. So let us assume I have an instruction. So let us assume I have an instruction like this. Let us consider move R0, comma hash 55. So I have an instruction like this, move R0, comma 55. Processor will not understand immediately its meaning. Processor should fetch the opcode from the memory. So let us assume I have a memory. So in this memory, the opcode have been stored. Let us assume the memory is there. So in the memory, opcodes are stored. For each instruction, various opcodes are stored in the memory. Opcode in the sense in the hexadecimal format, 0x123 or 0x234. So like that, various opcodes are stored in the memory. Processor is going to fetch the opcode for this particular instruction. So this is called as fetching. Fetch means fetching the opcode from the memory to the particular instruction. The second one is decode. After fetching, the opcode will be decoded from the decoder circuit. After decoding, ALU is going to be executed. So these three stages are called as a pipelining. So I'm going to execute all three stages in the parallel mechanism, or I'm going to execute all three stages in parallel. Is called as pipelining. Parallelly, I'm going to execute. First, I will execute fetch. During fetch, I'm also executing decode, and also I'm going to execute the instruction. So this is called as pipelining, and your ARM follows a three-stage pipelining. Okay, I hope this is clear to all. So we will move to the next point. Yes, your ARM processor follows a JTAG interfacing. So JTAG stands for Joint Test Action Group. This is used to debug the circuit, or it is used to debug the hardware. How, sir? That we will see in later videos. Yes, one important thing with respect to ARM is ARM uses 32-bit memory addressing range. Okay, so what is the meaning of this, sir? So I want to write one small thing here. So 32-bit memory space, addressing space is available. So when I calculate 2 power 32, so I'll be getting I'm getting 4 GB of memory. So that means I can interface up to 4 GB of memory to the ARM processor. So let us assume this is my ARM, and I can interface up to 4 GB of memory with respect to my ARM processor. So this is my 4 GB of memory I can interface with respect to memory with respect to ARM processor. So ARM processor can have a memory up to 4 GB. So this is a big advantage compared to any other processor. Next point. So ARM operates in 7 various operating modes. So what all those that we can see on the screen. So one is called as the user mode, second one is called as FIQ mode, third one is called as IRQ mode, and fourth one is called as supervisory mode, fifth one is called undefined mode, sixth one is called as abort mode. Okay, seventh one is called thumb mode, and one more thing I missed out here. So that is your system mode. So one more mode is there. So that is called as a system mode. So totally 7 different modes plus 1 extra mode. So 7 modes includes user mode, FIQ, IRQ, SVC, undefined, abort, thumb, and system mode. So totally 7 plus 1. So thumb mode is a special mode, and this is going to be operated in a 16-bit mode. And apart from this, so we'll be having totally 7 different modes. Okay, so these are all the features of your ARM processor. So guys, so we will continue in the next video lecture about the architecture. Thank you. So hi guys.